What is the rate of change of the volume V of hemisphere or of a hemisphere with respect to its radius r when r equals to... Okay, let's go over that again. What is the rate of change of volume V? So we've been given the volume of a hemisphere to be V with respect to the radius r when r equals to... Now this is a very easy problem, but the only area where I feel might just be a little challenging to some is how do you transcribe or transform this statement here to a mathematical statement, which is what I'm going to explain to you now in a jiffy. Now what it says is, what is the rate of change? So we want to find the rate of change of something. And of what? What is the rate of change of the volume? So look at the way I'm going to form my equation. The rate of change of volume, that is dV, the change in volume with respect to the radius. With respect to the radius r, we've been given that when r equals 2, that is at r equals 2. So it just says, so what the question says is, find dV dr at r equals 2. That's all it says. So the only bone of contention is, what is the formula for the volume of a hemisphere? Well, if you have not forgotten, the volume of a hemisphere is given by V equals 2 divided by 3 pi r cube. So this is the formula for the volume of a hemisphere. So there are two things involved in this statement here. So the first thing is dV dr, and the next thing is when r equals 2. So the first thing we are going to do is we're going to find the rate of change of V with respect to r. Then our answer would evaluate it at r equals 2. Now, let me write this in a clearer way. So you have V equals, so you have 2 all over 3 pi. 2 over 3 is a constant. Pi is also a constant. So 2 over 3 pi r cube. So we want to find dV dr. Now to find the derivative of V with respect to r, you recall again from calculus that says that if you have, say you have y equals x to the power, let's say to the power n, and you want to find the y dx, so the y dx is just going to be, so we say what you have here becomes a coefficient, this becomes n x, and then you reduce the power here by 1, then n negative 1. So this is just the y dx. So similarly, we want to find dv with respect to r. So since you're finding v with respect to r, every other thing is going to be treated as a constant. So dv dr equals, so we're going to leave our 2 over 3 pi the way it is because it's a constant. So what we need to take into consideration is only r to the power 3. So according to the formula we have here, it says that this is just going to be, so the 3 here becomes 3r, then to the power 3 negative 1, according to what we have here. So this becomes, so this is going to be 2 all over 3 pi times, so you have 3r, then 3 negative 1 is just 2. Now 3 here crosses 3, so you have is going to be 2 pi r squared. So in other words, dV dr equals 2 pi r squared. But it doesn't stop there. The question says find dV dr at r equals 2. Now dV dr we have here is 2 pi r squared. So 2 pi r squared here. So to find dV dr at r equals 2 is just simply going to be 2 pi. So anywhere you have r, you replace it with 2. So since we have r here, so we're going to replace it with 2. So this becomes 2 to the power 2. And that's just going to give us 2 pi, then 2 to the power 2 is 4. So 2 times 4 is going to give us 8 pi. So the dr at r equals to is just 8 pi. So let's check. Yeah, so here it is. So answer is C.